So your quiz, which is on Monday, but remember I'm not in class tomorrow because of movie night, is on 5-1 and 5-2. You can use a calculator. I would use whatever you're the most comfortable with. So if you practice degree, minute, second notation on a graphing utility, use your graphing utility, okay? If you're better off with your scientific because you're not really comfortable with your graphing utility, use your scientific. Doesn't matter. You're also going to get a bit of a reference sheet. I will post what it is, but because I'm not exactly sure what's going to be on it, but at least the Pythagorean identities will be on it. That I know. I don't know how much more we're going to give you, but I'll post that right on the quiz review assignment so you can see what it looks like. It's 9 questions because some of them have multi-parts, okay? But it starts with 5.1. And 5.1, we learned how to draw an angle on the circle. We learned how to find coterminal angles, which is adding or subtracting 360, however many times you need to do it to get, if it's positive, if you want a positive coterminal angle, you got to make it positive. If it's negative, you got to make it negative. So if mine was like a negative 1,000, I'm going to keep adding 360 until I get to positive. And then the converting from degree, minute, second notation to decimal degree, or vice versa, decimal degree to degree, minute, second.
On the quiz, would it ask us to round for one of the conversion ways?
I actually don't remember. I have to look at the wording on it. Yeah, I'll look. Yep.
Are we going to have to do the conversions by hand on the quiz?
No, you can use your calculator. Yep. So if it's degree, minute, second notation, let's say it's 27 degrees, 15 seconds, and 35 minutes. You'll want to practice either using the shortcut on your graphing utility that's under that angles menu, remember, and then the double tick mark is above the plus symbol. Or let's say you don't have your graphing utility, you're using a scientific. Let's say you forget your graphing utility on Monday and you have to borrow a friend's scientific and it doesn't have that shortcut. You take the 27 and then you do 15 over 60 because those are minutes and that's how many minutes are in an hour. And then you do 35 over 3,600 because those are seconds and that's how many seconds are in the hour. So whether or not your calculator has that shortcut, you should be able to find. All right, so this would be 27.25972 and so on. And then I think it says to round. I just don't remember what it says to round to. So just pay attention to whatever the quiz says. Yeah.
If you do it separately, do you think we should round 15 over 60?
Whatever it says to round to, I would keep one more digit than that when you're rounding along the way. So if it says to round to the nearest 10th, keep 2 decimal places because that's what's going to tell you to round. If it says to round to the nearest 100th, keep 3 decimal places because, again, that will tell you, do I round it up or do I round it down at the end? Okay, then degree, minutes, or decimal degree to degree, minute, second notation, you literally can just write it in. So if I had 27.259, let's say, degrees, I type it in, and I arrow DMS, which is the easiest way to do it. And that gives you 27 degrees, 15 minutes, and 32.4 seconds. If you don't have that button on your calculator, then you take the 27, and that's your degree. I take the 0.259 and I multiply it times 60. And I get 15.54. And the 15 becomes the minute. And then I take the 0.54 and I multiply it times 60. And I get 32.4 and that becomes your seconds. So figure 2 questions like that. Practice, check, check. Yeah.
When you're doing the decimal degree to degree, minute, second, do you put the degree symbol?
When you're writing out the answer, you mean?
Yeah.
Yeah, so the 27 should get the degree.
Like you put it in the calculator.
Oh, no, you don't need it.
Okay.
Yeah, you don't need it in the calculator. Mm-hmm.
For the seconds, we can have 32.4, right?
Yeah. It'll terminate at some point and you would keep it. Okay, so going back up to drawing the angle, okay? Remember your quadrant angles. So we used them again yesterday in 5-1 or 5-2, but this would be 0, this would be 90, this would be 180, this would be 270, and then it would double back around to 360.
Is that going to be on the reference sheet?
No. Yeah, no. For sure, none of that stuff will be. Like, it won't say SOHCAHTOA. It will just be, if anything, the reciprocal identities, the trig identities, and the, what else do we give you? Not the intervals won't be on there. None of that would be on there. Yeah. All right, so if I had an angle that was like 545 degrees, I can do this a couple different ways. I could go all the way around my circle once, that's 360. And then I could find the coterminal by subtracting 360, which is 185, which means past that 360, I'm going to 185, which puts it in the third quadrant. If you have an angle that is that big, you do have to show that arrow. You got to go around it more than once. You're going to show that loop, okay? If it said negative 545, I'm going the other direction. So all the way around negative one whole time, that would be negative 360. I would do the same thing. This time I'm going to add the 360. I'd still end up, now I get negative 185. So then this would be negative 90, negative 180, negative 270. So I'd go past the negative 180. And my angle would go in the second quadrant. So it's going to ask you to find the coterminal, and then it's going to ask you to draw it.
The first quadrant's top right, right?
Correct. Yep. 1, 2, 3, 4.
When
Yeah.
we draw it and it's a negative number, do we also have to have the negative like 360 or negative 90?
You don't have to have it written, but you've got to do the scoop. You got to show the arrow in the direction that you're going. So you got to make sure you're going clockwise instead of counterclockwise.
Do we have to value all the points
Huh?
of like the negative?
No, that's what he's asking. No, you don't have to label it. It's just an empty coordinate grid. Yeah. Obviously, I think it's helpful to label it, but you don't have to. Camilla.
When it asks for like drawing an angle and it gives you the answer, you have to do like the smallest negative number and the.
It's going to ask for a positive and a negative coterminal.
Okay.
Yep. Questions on 5-1? This is what you're getting. Just the reciprocals and the Pythagorean identities. Oh. All right, 5-2 is all the other stuff. So we just said 5-2, you're going to get the reciprocal. I'm going to put it on this slide too. You're going to get the reciprocal identities, and you're going to get the Pythagorean identities given to you, okay? But obviously then you need to know how to use them. So in 5-2, we revisited SOHCAHTOA. You have to know how to spell that word. That word saves lives, okay? If you want to write it as soon as you get your quiz, that's fine. That is sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. You want to know your Pythagorean triples that are common: 3, 4, 5, 5, 12, 13, 6, 8, 10, 7, 24, 25, and 8, 15, 17. Those are also going to save some time. You want to know your quadrant angle coordinates. So at 0, 90, 180, 270, and 360. This is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And then you need to know that cosine is your x, sine is your y, and tan is your y over x. So those are anything that have the degree measurement in the question, which is what's like stuff that was on the homework. If it says 270, I'm going to 270, I'm figuring out which one's which. If it said something sine of 180, I'm going to 180 and grabbing the y. If it says cosine of 90, I'm going to 90 and I'm grabbing the x. If it says secant, cosecant, or cotangent, then we flip them. Camilla.
Isn't it like cosine equals x over r?
If you have a radius, but in this circle, this is a unit circle. The unit circle has a radius of 1. So it is x over r if you want to remember x over r. But r in this circle is 1. So you don't need it.
Oh, okay.
But that's only for the ones that have the degrees. So that's, remember, that's what I messed up yesterday when I was teaching you the 0, 2, and the 2, 0, that stuff. Then you need the R. So this is only if it says, find 3 sine 90 plus 7 secant 270. Like, unless it's that. Does that make sense?
So, okay, so you can,
Which was a bad example because that's undefined. But
okay.
cotangent 270. Something like that. Yep.
So if it has like a coordinate point,
If-
triangle, then
Then you set up the triangle. Yeah. So this is just the angle-based questions. Yeah.
What if the point is like 2, 0 or something?
So now that's different, right? Okay, so then we get onto if it gave the coordinate points, and there was 2 different types. So if you gave the coordinate point, and it was non-zero, so it's -5 and 7. This, you set up a triangle. So you're going to plot it in the quadrant that it's supposed to go in, set up your triangle, figure out your trig functions. So if it's -5, 7, I'm going left 5, and I'm going up 7. And theta goes in the corner. 5 and 7 is not a triple, so I would then use the Pythagorean theorem, which is also something you need. A squared plus b squared equals c squared, where c is the biggest, or the hypotenuse. So I would get -5 squared plus 7 squared equals c squared. The negative goes in parentheses because it's going to go away. 25 plus 49 equals c squared. C squared is 74. C is the square root of 74, which is 2 and 37. Doesn't go anywhere. So it's going to stay just like that. And the radius is always positive. Rodrigo.
for the a squared plus b squared, does it matter which coordinate goes where for a and b?
Nope.
Okay.
Oh, why did it go second? Valeska. Correct. Good morning. Do you come for my money? All right, so now I'm going to set up each of these based on like SOHCAHTOA. So sine would be opposite, which is 7 over hypotenuse, and then we rationalize 7 square root 74 over 74. If you can reduce it, you reduce it. Cosine, -5 over root 74, which becomes -5 root 74 over 74. And tangent 7 over 5, -7 over 5, or 5 over 7 over -5, doesn't matter. Okay, now when I go to do the cosecant, and here's the trick on the reciprocals when you've got square roots. You want to go back to before you rationalize to flip. Otherwise, you are going to re-rationalize something you already rationalized, and you're going to spend a lot of time doing it. So you're going back to before you rationalized and flip that. So this would be square root 74 over 7. This would be square root 74 over 5, and it's negative. And this would be -5/7. So before you rationalize. Yep.
Would it be wrong if we didn't?
No, you just have to you're going to have to multiply by the square root of 74 in the top and the bottom. And then you're going to have to simplify. So it's like 3 extra steps you don't have to do. Granted, you're going to have a calculator, but it will be messy. And none of that will be rounded. So like that's the caution with the calculator. Don't try to type that in to solve for the missing side and put a decimal. It will get marked wrong. It has to be kept exact. Okay? Questions on the coordinate points if not 0. Okay, then comes coordinate points if 0 is involved. So if it said coordinate point -3, 0. If one of them is 0, think about where that would go. -3 would be to the left 3. There would be a point plotted there. There is no way to make a triangle from this. And this is where you need cosine is x over r, sine is y over r, and tangent is y over x. And then again, flip it to get the others. There's 2 ways to find r. R is the square root of x squared plus y squared. That works every time. But when when one of your coordinate points is 0, you could simply just count your radius. You went left 3, so your R is 3. Whatever direction you go, up, down, right, left, whatever that distance is, that's your radius. There's no way to set up a triangle there. So you'd have to do cosine is negative 3 over 3, which is negative 1. Sine is 0 over 3, which is 0. Tan is 0 over negative 3, which is 0. And then we flip it to get this the secant would be 1. This should be negative 1, sorry. Negative 1. Cosecant would be undefined because that's the reciprocal of 0. And cotangent would be undefined because that's the reciprocal of 0 again. Yep.
The radius would be, because like I did the long version.
Uh-huh.
And I got
You should get square root 9.
I got 3.
You didn't square the 3. Negative, yeah. It should be the same answer. Questions on those? Yeah.
Is there any point where you can't make the radius how many times?
If one of them's not 0. So like if I wanted to use, because I could do the same method with this one without drawing the triangle. I could make R equal to negative 5 squared plus 7 squared, and then I could do X over R, Y over, I could do the same thing. I would assume most people are more comfortable with SOHCAHTOA than they are that, so that's why I teach the other way. But you could totally do these the same way.
Okay, and then when there's a 0, you could always do it?
Correct.
Okay.
Yep. Any other questions? Yep.
And then you wouldn't have theta because you can't make a triangle, right? Like for secant.
Correct. Yep. Anything that has a 0 as the X or the Y, you cannot make a triangle. Okay, so then you had ones where it would say something like, oh, hang on 2 seconds. Tangent of theta is negative 5/6. And it's in quadrant 2. Okay, so first of all, this is the trick I want to teach you, okay? This acronym helps you remember what's positive and negative. Instead of doing the X's and the Y's like we did, they're both positive in the first quadrant. It's a negative X, but a positive Y in the second quadrant. They're both negative in the third quadrant. The X is positive, the Y is negative in the fourth quadrant. That then leads to the trig functions. But there's also an acronym that says all students take calculus. So that stands for which of the original 3 trig functions are positive. So in the second quadrant, sine is positive. Cosine and tangent are negative. In the third quadrant, tangent is positive. Cosine and sine are negative. In the third quadrant, cosine is positive. Tangent and sine are negative. And then the reciprocal functions take on the same sign. So not only is it sine, but it is also cosecant. Not only is it tangent, it is also cotangent. And not only is it cosine, it is also secant. Those are what's positive in those quadrants. Everything else is negative. Yep. Mm-hmm.
What's the A?
All. Yep.
It's because cosine is higher than 70.
Correct. Like you could get there based on what we talked about, but that eliminates maybe like a step. Okay. So if you're given this question, let's say it says tangent of theta is negative 5/6. And I want to find all the other trig functions. So I want to find sine. I want to find cosine. I want to find cosecant. I want to find secant. And I want to find cotangent. Before I even get to the values, I could go through and give which one's positive and negative based on the location of that angle. So because it's in the second quadrant, sine and cosecant are positive and everything else is negative. Then all you have to worry about is the signs on the actual trig functions. Should I write this? The sine and cosecant are positive and everything else is negative. If it's in the second quadrant, right, because it gives you this information in these types of questions. It says it's in the second quadrant. If it's in the second quadrant, and we just said this, sine and cosecant are positive in the second quadrant and everything else is negative. before I even get to the values of the sides, I could go through and give it their distinctive sign. So sine and cosecant would be positive, but cosine, secant, and cotangent, and tangent, which is what they gave you, would all be negative. Claire?
What about if it was tangent?
If it's tangent, it would be negative. Yeah, which is what they gave you, right? They gave you tangent and it's negative. Okay, Camilla.
Sine equals X.
Sine is the y. But that's not for this. That's for a coordinate grid.
Oh.
That's for a coordinate. Now we have to set up a triangle. If you're given a ratio, you got to set up a triangle. All are positive. Everything's positive in the first one.
Oh, like if you get tangent and then it's saying it's negative, the sine and the cosine. So the tangent is negative and the sine and the cosine are positive?
Correct. Because it'd be a negative over a negative.
Oh, okay. And then like if it was sine, then I'm just confused because there's two signs in the sine.
So I'm going to draw it. Because again, if that confuses you, that should help you. But if it confuses you, don't use it. Then I go to the next thing, which either way, I have to end up drawing my triangle. It's in the second quadrant. So I'm moving left and I'm moving up. Because that's what an angle in the second quadrant would look like. I move left and I move up. Now tangent is opposite and adjacent. And that negative could go with the 5 or the 6. I don't know yet where that negative goes until I know what quadrant it's in. So because it's in the second quadrant, my x is negative, which would be the adjacent side. This one's going to have the negative. The opposite is the y. That one's going to have the positive. So then opposite is the 5 and adjacent is the 6. And I would use the Pythagorean theorem to find the hypotenuse. 5 squared plus negative 6 squared equals r squared. 25 plus 36. And r is the square root of 61. And that is always positive. Hypotenuse is always positive.
Don't we also know that, like, because it's tangent, that it's y over x?
Mm-hmm.
So we could just say that it's...
Y is the opposite, and the x is the adjacent.
Okay.
Yep. Yep.
Why do we have to find out which one was negative?
Say that again.
Why do we have to find out which one's negative? We square both of them.
To get the side length, you don't need to. But to get your trig functions, you got to know which one's positive, which one's negative. Unless you do what we did in the beginning. If you do what we do in the beginning with this stuff, then I could totally make them all positive because I already gave them their signs. So it's one or the other. So like sine of theta would be opposite, which is 5, over the hypotenuse, which is the square root of 61. And we'd rationalize 5 root 61 over 61. And it's positive, which makes sense, because it's sine in the second quadrant. Cosine is adjacent over hypotenuse, so it's negative 6 over square root 61, and then we'd rationalize negative 6 root 61 over 61, and it's negative, which makes sense because in the second quadrant, cosine is negative. Then I flip it, but I go back to before I rationalize, so this would be square root 61 over 5. This would be negative square root 61 over 6. This would be negative, the reciprocal of what I got at the beginning, so 6/5. Or adjacent over opposite if you want to use the triangle. Yep.
Oh, so because that sine is in the second quadrant, it's the y, so it would be positive.
Correct.
So that's how that works.
Yep.
Okay, I just got it.
Yep. It's important. It's good that you got it. Yeah. Some people have a mental block on it. And I mean, you have until Monday to actually let this sink in, but obviously I'm not there tomorrow, so I just want to make sure I clarify everything today. Okay, and then the last thing would be using the, so if they give you a ratio or they give you a value, because it could have also just said that tan of theta equals 7, and I would make that a 7 over 1, and then I would make my triangle from that, okay? So it doesn't have to be a fraction. It could be a whole number. I think there was one in the homework like that. You had to put it over 1, and then you had to make your triangle. And then the other kind are using the Pythagorean. identities, which is which will be given to you. Sine squared plus cosine squared equals 1. Tan squared plus 1 equals secant squared. And 1 plus cotangent squared equals cosecant squared. Huh? Yes.
What about the ones?
I showed the picture of what's on there. If you want, I'll go back to it at the end. But I showed the exact picture that you're going to get, like twice. Yeah. I'll go back to it at the end, but not now. Yeah.
It says use the Pythagorean identities.
You have to use the Pythagorean identities. If you have time to check it using your triangle, you can. I mean, you totally can. But I'm looking for the work for the identities. And if you don't have it, it's going to get marked wrong.
And then if we just have the identity, can we just like plug in?
Yeah, so like, let's say I use the same thing. Tan of theta is negative 5/6, and it's in quadrant 2. And let's say, we'll go easy. Let's say we want to find secant, okay? And then I'll show you what to do if it wasn't that one. So what I do is I go, what did they give me? They gave me tangent, and then from there, I go and pick the one that has tangent in it. It has nothing to do with secant at the end. I got lucky that it's going to be both, but it could be tangent and sine. And I'll show you how to eventually get there. What you pick depends on the information they give you, not what you're looking for. So then I would say tan squared plus 1 equals secant squared. Negative 5 squared plus 5/6, sorry, plus 1 equals secant squared. 25 over 36 plus 1 would equal secant squared. This would be 25 36 plus 36 36. And you get 61 over 36. And I square both sides, square root both sides. And I get square root 61 over, don't forget to square root your denominator. You guys tend to do that a lot. That's the secant. Now the difference is, I got to figure out, is it plus or minus? But if I use my little shortcut, where all students take calculus, I almost slipped up, then the secant takes on the same sign as cosine, and in quadrant 2, what's the sign, positive or negative sign, of cosine? It's negative, so I would make that negative square root 61 over 6. Mm-hmm. Go ahead, Valentina.
Can you repeat the thing you just said about the cosine?
So, like, the secant, if it's a reciprocal function that they're looking for, because a lot of times it is, you got to say that reciprocal function matches which of the originals. Because it's secant, it has the same positive or negative sign as its reciprocal, which is cosine. So then in the second quadrant, I say, what does cosine have? And in the second quadrant, cosine will be negative, which means secant is also going to be negative. And that's how I know to pick that negative sign.
Okay.
So if it was in the third quadrant,
Wait, so the thing in the second quadrant, the S stands for C?
no, that stands for sine. That's what's positive. So sine is positive, which means cosecant is positive in the second quadrant. Those letters are just of your original 3 trig functions.
Okay, so since secant and cosine are not in the second quadrant, like, they're not positive. in the
Correct,
second-
then they have to be
Cosines are
negative.
Okay,
Yep.
makes sense.
Yep,
I'm kind of like doing the same thing, but because sine is positive, then it would be negative.
correct. Sine and its reciprocal function, which is cosecant, are the only things in the second quadrant that are positive. Everything else is negative. Claire? Because it said quadrant 2. I said quadrant 2. Yeah.
Can you show how to determine whether it's positive or negative without using the shortcut?
You'd have to know that it's in the second quadrant. So it's left and up. The x is negative, the y is positive. And then because secant is the reciprocal of cosine, secant would be hypotenuse over adjacent. Hypotenuse is always positive. So it'd be a positive over a negative, which is still negative. Yep. So if it had asked, let's say it asked for sine after all of that, like after I get to that point, it asks for sine. I would use this ratio, or I could use the tangent ratio at the beginning. It doesn't matter which one. I would use that ratio to fill in my triangle. So I would get that the secant, which would be the hypotenuse, square root 61, over the adjacent side, which is -6. That gives me 2 of the side lengths. If I go back to the tangent at the beginning, I have opposite is 5. Now I've completed my triangle. And if I want to get to, let's say, sine, it's opposite over hypotenuse, which would get rationalized. So it may not always ask you for the one that's in the Pythagorean identity with it. Like, I think on the homework you had one that was and one that wasn't. You've got to use, if it's not in it, so if I had tangent and cotangent, well, not cotangent. Let's say I had tangent and cosecant. I would use the first trig identity to find the missing side, to find the missing trig function, set up my triangle, and then from there I can use the triangle to get to the other one. Kylie.
This is kind of off topic, but is there gonna be ones in the quiz that were like, is this possible?
No. Yes.
How does the like use this possible work? Is that what
That's the, so if it's sine or cosine, it has to fall between -1 and 1. So if it says sine of theta is 3.5, not possible. Sine of theta is 0.35, possible. Has to fall between -1 and 1. Secant and cosecant are outside it. Has to be bigger. Why did I write cosine? Cosecant. Because you're doing the reciprocals of those. So if it said secant of theta equals 3.5, possible. Secant of theta equals 0.35, not possible. And then tangent and cotangent are any of it. Any. For tan and cotangent. The one question that wasn't possible with tangent and cotangent said that they were both 2. They can't both be 2, because if one is 2, then the other one's a half. That's the reciprocal of it, right? They can't be both 2 at the same time. Individually, tangent can be 2 and cotangent can be 2, but they can't both be 2 at the same time. Does that make sense?
Yeah.
Okay.
And we're not gonna be asked that on.
No.
What about the 10?
I don't know. Camilla.
Can you go back to the problem?
So at 0 degrees, right, which is this coordinate point, secant's the reciprocal of cosine. Cosine is 1 because it's the x. The reciprocal of 1 is still 1, so it doesn't matter on that one.
So you have to find like cosine.
And then flip it. Yep.
Oh, so then if it's like
Well, cotangent, I think it's not set, but I could just do x over y. You could do y over x and then flip it, but cotangent is also x over y. So at 90, it would be 0 over 1, so 4 times 0.
Oh, so okay, so it has to be with cosine, sine, and tangent.
The original points, if you do cosine is x, sine is y, and tangent is y over x, you've got to get to that point.
Oh, okay.
Oh, so
Because on the circle, secant's not already there. You'd have to find cosine and then flip it. Cosecant's not already there. You'd have to find sine and flip it.
Is cosine x.
Correct.
So then you would have to.
Yep. So then the cosine at 360 is 1. So this would be cosine, or sorry, this would be 1. And then it's 2 plus 0 plus 1.
And that's only because of the 1, 0. It's not okay.
Yep. The ones that have the angles only use those quadrant angles. So quad 3 looks like that. And tangent's positive, which means the sine is going to be negative. Wait, is secant negative too?
No, it's positive 2.
And it's in quadrant 3?
Yeah. Wait, no, quadrant 4.
Okay, I was like, something's wrong with me. 4. That's okay. Otherwise, it doesn't line up. Okay, so quadrant 4 now makes sense. Cosine's negative. Cosine's positive, which means secant's positive, which makes sense because it's positive 2. But then sine would be negative. So the sine already, like positive, negative sign, I know is negative because it's in the 4th quadrant. Then secant, I'm going to make this into a fraction. So that's 2 over 1. Secant is the reciprocal of cosine. So you can either say cosine is the reciprocal, which is 1/2, or The reciprocal of adjacent over hypotenuse is hypotenuse over adjacent. And you could use that. So you either take the 2 over 1, flip it, and that's your cosine, which would be adjacent over hypotenuse, or flip the letters. If cosine is adjacent over hypotenuse, or secant is hypotenuse over adjacent. So this would be 2 and this would be 1. And this would be root 3, but it's negative.
Could you explain why it's negative again?
Because it's in the 4th quadrant. So your x moves forward, so it's positive, but your y moves down, so it's negative.
Oh, okay, yeah, that makes sense.
And then the sign would be root 3 over 2. Because it's opposite over hypotenuse.
Because it's the secant negative 2, that's why it's positive, because it's in the fourth quadrant.
Because it's in the 4th quadrant.
That makes sense.
Yep.